we have seen that big data is both structured and unstructured. Column-oriented databases is one type of databases that is specifically designed to process unstructured data. HBase is a tool that can be used to process column-oriented databases. HBase is also available in the Amazon Web Services cluster. So in this tutorial, we are going to learn how to manipulate column-oriented databases using HBase. Specifically, we're going to learn how to create tables with HBase, how to load data from big data files into these tables, how to do some simple analysis of the data, filtering, scanning, and so on. Before we start, make sure to check datapower.com/hbase.html so you can download any necessary files that are needed for this demonstration. Let's start. Cluster is up and running, and to invoke HBase, we simply type HBase shell. The status command shows the cluster status at different levels of detail. For example, we can do simply status, or we can type status simple. Gives you a different level of detail. Status summary is the default level. Will give you the same level of details as simply status. Or we can type status detailed to receive much more details in the status of the cluster. We can also type version to see which version of HBase we are running. Just as with SQL databases, in HBase we have data definition commands and data manipulation commands. Let's start with some data definitions. In other words, let's create some tables. Let's create our first table. This command shows that my first table is created with a column family name of family1, allowed to store up to 5 versions of records. Now we create my second table, which has column families named family1, family2, and family3. My third table is the same as my second table. It's a shortcut version when no other properties besides column family names are required. There are many configurations assigned to these tables that we are creating. These configurations are assigned by default. For example, if we type describe my first table, we will see these configurations which are set by default. We can always change these configurations. For example, let's create another table called my fourth table, which has some specific configurations. For example, TTL 2,592,000 means that the family column will be automatically deleted after so many seconds, 2,592,000 seconds. Assigning block cache to true means that the values in this column will be placed into a read cache, which accelerates the read operations. The default value for this option is true if it's not specified. Now let's create another table called my fifth table. As you can see in the configuration part in the command, my fifth table is set to have 10 blocking storage files. By default, this value is 7. This means that when values are added into the column family, these records are stored in the HBase memory. Every time the block size is reached at that memory, the data is moved into a new storage. Now let's try to change those tables that we have created. For example, the command alter my first table, name family1, version 3, will change the family1 column in my first table. So from 5, we now have a maximum of 3 cell versions. Now let's list all the tables that we have created by simply typing list. If you want to delete a table, you must first disable it. So let's disable my second table, type disable, my second table. We get an error because the names are case sensitive, so let's correct, make a capital T there, and the second table is disabled. Let's check the status of that. Let's type is disabled, my second table, and we should get a response true. Once a table is disabled, we can delete it by typing drop table and the name of the table. We will not do it here, but let's just start entering some values into these tables. Here's the command. We are placing in table my first table, the record 100, the row 100, the column family 1, and the price of $45. If we do a scan my first table, you will see the record already entered into the table. Now let's enter multiple values. Let's go to the text document which is already on the website and copy several put commands. Here are the put commands. Highlight them, do a Control-C to copy them, and come back to the terminal and paste. Hit enter to execute the last put command. If we do a scan my first table, you will see the records, the values already entered. Count my first table will show you how many rows this table has. It has a row 100 and 101, so 2 rows. What if we want to delete a value? Each value can be reached by using the name of the table, the row, the column, and the timestamp. For example, if we type delete my first table, 100 family 1 price, and now let's get the timestamp from above, so I'm going to copy and paste here. Just Control-V and paste. We will delete the value 55. So let's do a scan my first table. You will see that the value 55 is deleted. You can delete the entire row by simply using the row number. Delete all, my first table, and enter row 100. Hit enter, and if you do a scan, you will see that row 100 is removed entirely. This was a brief tutorial on how to create NoSQL tables using HBase, and how to enter data into these tables, and how to retrieve these data from the table using the table name, the row, the family name, and the timestamp. Now let's create another table named custom. This is a customer table that has more columns, has an ID, customer name, the address is a family name, 3 versions, demographics is a family name, payments, and the number of versions for payments. So let's create this table. Now let's do some put commands here. Put customer 171, customer name, first name, Madeline. So we are entering some data. Notice that to enter the first name and last name, we use the custom name, which is the family name, and then use colon first name. So we can enter this data. We can enter more data here. For example, we are entering the address here as the street name. The column name is street name under the address. We can also enter the address for the same customer, but a different address, which means we are storing another version of the street address. So we can actually enter the same put command twice. It's still going to accept it because for every put command, a new timestamp is recorded. As long as we allow multiple values through versions, we will be able to record. I'm going to paste multiple records and we'll do a scan to see the final results. And here are the records that I have entered. As you can see, we have row 171 and 172, but multiple values that are going into these rows. So if we do a count customers, we only have 2 rows. Now we're going to learn how to load an entire file. Instead of using the put command, we're going to load an entire file into HBase. To do that, first let's go to the Hadoop prompt. Type exit will take us to the Hadoop prompt. So let's do nano customers_records.csv and paste the records that we have copied from the file. So here is a list of records. We have a row 171, 172, so we have multiple rows for different customers. Let's save this file. Now let's create a directory, Hadoop fs minus make directory HB. Let's create a subdirectory here, input. And let's move the customers records CSV to this subdirectory. Now let's go to HBase, type HBase shell. Let's create a table customers. Create table, customers, CF1 column family called CF column family. Table is created. Let's type exit to go back to the Hadoop prompt. Now let's use an import command as follows. By the way, you can copy and paste this command from the tutorial provided on the website. Here are some components in this command. HBase prompt, import TSV class, indicating that the values are separated by comma, import TSV function on the columns, the row key, then columns in the customers table, such as first name, last name, street, city, state, zip, year of birth, gender, internet, credit card, mobile. Next, we indicate that these data should go to the customers table on HBase that we have created, and the source of this data is from HB input customers_records.csv. Hit enter to execute the command, and let's check if the records have moved into the customer table. Let's call the HBase shell, and if we do a scan customers, you will see that the records are already placed in the table customers. A total of 13 records are placed in a NoSQL format and are ready for manipulation. This is how we import data from large files into an HBase table. I hope you enjoyed this introduction to NoSQL databases and HBase. As always, let me know if you have any questions. If you want to learn more about big data analytics, subscribe to this channel. Also, follow me on Twitter at Professor Benny or join my LinkedIn network. You can always email me with any questions.